At this point in the module, I've introduced you to two main ideas related to rotational motion. First, I've introduced you to the torque. Simply put, we can say that the torque is the twist delivered to an object by a force. Another way of saying that is that the torque measures the effectiveness of a force in changing an object's rotational motion. I have also introduced you to the moment of inertia. The moment of inertia is a measure of the resistance of an object to change in its rotational motion. We'd like to see how these ideas fit together to describe the actual rotation of an actual object. In order to do this experiment in a way that you can see the torque actually changing, here's what I'm going to do. I'm going to be pushing on the spice tray using a Q-tip, and the Q-tip is kind of flimsy, so that limits how much force I can apply. So then, in order to let you see that I am varying the torque, I'm going to change where on the spice tray I'm pushing with the Q-tip. So remember that the torque depends on the distance between the point where the force is applied and the center of rotation. So if I'm applying the Q-tip to a point close to the center, that would be a smaller torque. But then as I move the Q-tip further away, that will be a bigger torque. So I'm going to start by applying a small torque by coming in close to the center of rotation, and then we'll see how much angular acceleration I get. Okay. You can see that when I applied the Q-tip close to the center of rotation, in order to get a small torque, the resulting angular acceleration was fairly small. Now let's say I go further from the center. So here I'll have a bigger moment arm, which means I'm going to have a bigger torque. And you can see that in that case, I got a bigger angular acceleration. And if I now come all the way out to the edge, okay, so I hope you can get the idea from the demo that the bigger the torque, the bigger the angular acceleration that results. The next question is, how does the angular acceleration of the spice tray change as I change the moment of inertia? Now we'd like to see how the angular acceleration depends on the moment of inertia. So here's how I'm going to vary the moment of inertia. The spice tray all by itself will have the smallest moment of inertia. But then if I add these two masses to the spice tray near the center, that increases the moment of inertia. And then as I take the masses and move them further from the center, that even further increases the moment of inertia. So I'm going to do several trials here. In each trial, I'm going to apply about the same torque using my Q-tip. But then as I go from one trial to the next, I'm going to take the masses and move them further from the center to change the moment of inertia. So let me start with the smallest moment of inertia, which would just be the spice tray by itself.